Howdy, here's the lesson 1.4.1 study guide on we're talking about representing proportional relationships. So you got it. So how are you going to see it? And we're going to start with graphs. And so right here we see complete the statement. Okay, proportional quantities are represented by, and we should know this one by now. It's represented by equal ratios. Now we have this in here, and we have our x and y values, x values, y values. Now we could also present these as ordered pairs, where it would be 1 comma 2, 3 comma 6, and 5 comma 10. Ordered pairs, a pair of numbers is an order to them. So you place the first one, 5 on the x and 10 on the y, so 5 on the x and 10 on the y. 3 on the x and 6 on the y, 3 on the x and 6 on the y. And then 1 and 2, 1 on the x, 2 on the y. And then as you draw a line through these, they should all actually find their way down to 0, 0. So if we continue looking at the graph does go through the origin. So it does go through the origin. And as we look at these items here, 2, 1, 6, 3, 10, 5. And so, what, 6, 3 should be 10, 5. And all of that is equal to 2. Yeah, well, so it's 10, 5, which is equal to 2 over 1, which is equal to 2. Okay. And what does that mean? Well, it means that the y value is always twice the size of the x value. So if we're going to talk about unit rate, and I'm just going to go a quick aside here, the unit rate is equal to 2, and the constant of proportionality, which we know as k usually, is also 2. So that means that the y value, I can bring it back over here, every y value is twice the size of every x value. That's why it's going up pretty steep there, and that constant proportionality is that. So the quantities, they are in proportion. It's a straight line. It's a straight line. It goes through the origin right there. Those are the two things you need to know. So on this one here, let's see. We have 1, 3, 1, 3. Okay, 4, 9, 4 on the x, 9 on the y, and 5, 11, 5, and 11. Now this is a straight line, but it doesn't go through the origin. So does it go through the origin? No. And take a look at this. If you take the y value, like 3 over 1, done. That's not equal to 9 over 4, and it's also not equal to, is it equal to 11 over 5? No. Is it equal to 11 over 5? No. So there you go, and it's not going through the origin, so they are not in proportion. Okay. Complete the statement. In a proportional relationship, the ratio of the y value to the x value. So the ratio of the y value to the x value is in simplest form is the constant of proportionality, or k. And we should know that before. There's a couple of equations. Y is equal to the constant times x, and the constant is equal to y over x, which brings you back over here. Okay. So let's see what we got here. So what do we got? We got this straight line. It goes to the origin. It must be proportional. Use 2 comma 6 to find k. Well, this is the x and this is the y. So y over x is going to be 6 over 2, which is 3. Use 9, 3. Well, you can do y over x is equal to 9 over 3, which is also equal to 3. So that's the constant of proportionality. It's also the unit rate. And here, if you want to see this, anytime that you have a proportional relationship, so it's straight line going through the origin, if you go to 1, you'll always see the unit rate right there. See? And that is the same as this. It's all tied in. Explain how you know the relationship is proportional, includes 0, 0. So we can say, right here, you say the constant of, okay, that's the word of, the constant of proportionality, which is k, is 3 at every point. So the line, oops, that's a period. The line passes through the origin, and which is 0, 0. So at this point, so this is a proportional relationship. Okay, so that spells it out for you right there. The main idea here, we're using equations of proportional relationships. So we're going to complete the statement. I then identify the constant proportionality for each equation. You can write the equation of the proportional relationship in the form of y equals kx. So we have the equation y equals 4x here. Y equals 4. What is the constant proportionality? It's 4 right there. I'm pointing to it. It's y equals kx. So that's 4. For this other one, y equals negative 4x. So that's negative 4. That's the constant of proportionality for that one. And for the last one, it's pretty easy. Oops. It's pretty easy once again. It is that number. They call it the coefficient. Whatever is in front of the variable is the coefficient. So the coefficient of x is 1/4. And so that is also the constant of proportionality. Complete the steps below to show how you can use the graph of proportional relationship to write an equation. So you have to choose a point on the line. A point on the line, and find the k by dividing the y value by the x value. If necessary, simplify the ratio and substitute value of k into the equation y equals kx. So those are the steps. Those are actually steps that we were just working on. So apply this very process here to this right here. So let's find a point on the, so if I look at this, find a point on the line. Let's use 4, 8. Okay, find k by taking the y value divided by the x value. So it's going to be 8/4. And then you simplify the ratio, which is 2/1, which is 2. And then you so I just simplify the ratio. So I found the point on the line, done. I find k by dividing them, done. 8/4. Simplifying it, 2/1 or 2. And then I substitute y equals kx. Well, k is equal to all this, so it's y equals 2x would be our equation. So if I do that here, I couldn't fit it all in the same thing. So what it was, the point was for 8. Divide, that'd be 8/4, which is 2. So it's y equals 2x. And then the main idea, we're interpreting points on the graph. So the graph shows prices for different different numbers of pizza slices. Okay. In the real world, what is the meaning of 2/4? So we have the point 2/4. So we have 2 slices, number of slices. 2 slices cost $4. So I could write 2 slices cost $4. What's the meaning of 4, 8? That would be 4 slices cost $8. And for a proportional relationship, the unit rate of the y-coordinate when the unit rate is the y-coordinate when x is equal to 1. Which point represents the unit rate? What is the unit rate? So when x is 1, let's see. When x is 1, when the x value is 1, it's 2. So right there. Let's see what we got here. What is the unit rate? Which point? Well, 1, 2 represents the unit rate. What is the unit rate? It is the unit rate is 2. The unit rate is the same as k. So it's a unit rate equals 2. Or $2 per slice. SLIC. Oh my goodness, are you kidding me? You gotta be kidding me. Per slice. Okay, so we have here, now we're going to be solving real world problems with proportions. And in this problem, let's see if I can get this going here. I got to make it smaller so I can fit the whole thing in here. So Sean swims laps, 12 laps in 6 minutes. If she swims at a constant pace, how many laps can she swim in 7 minutes? Complete the steps. So identify, so the x value, the x value of the number is going to be the number of minutes, okay? And so the y value is going to be the number of laps. Okay, so find the constant of, that's of, find the constant of proportionality. So k is going to be a y value divided by the x value. Oh, which is, I would have done, oh yeah, which is the y value, which is the laps divided by the minutes, and it's 12 divided by 6. So k is 12 divided by 6, so that means it's 2 laps per minute. Write an equation in the form of y equals kx. So y equals 2x, because k, if I bring y equals kx, and 2 is the k, right there, k is equal to 2. So if we have, so we substitute the information now, because we want to know the x. So for 7 minutes, okay. So we substitute, because it was asked, well, how far should you go in 7 minutes? So it'd be y equals 2 times 7, and 2 times 7 is 14. Okay, we have some key terms here I'm going to define for you. Okay, I went ahead and typed this stuff out. So constant proportionality, that's a really big deal. And here, the constant that relates to variables in direct variation. So so if y equals kx, k is a constant proportionality. Also, the constant proportionality is the unit rate. Okay. So proportional quantities, they're always in the same ratio. They make a proportion. I think I'll also say that. Make a oops, I gotta move this proportion. All right. And then what is a ratio? Well, it's a fraction, okay? But you can write it as with a colon, like that right there. And a colon b is the same thing as a over b. They mean the same thing. So I'll leave that there for you. And finally, the last one is, what is a unit rate? Well, a unit rate is really just a rate with a 1 for a denominator. Also, I'm going to link these two. I think you should do the same. So right over here, the constant proportionality and unit rate, they're always equal. they're equal to each other, the same. If the conf is con if the cons if the constant of proportionality is 4, then the unit rate is 4. Okay, it's that simple. All right, I hope this has been helpful. Thanks for watching.